Hello students, welcome back to Chemical Kinetics. In this module, we will see what is molecularity of a reaction. For that, I want you to consider the equation for formation of ammonia, that is N2 plus 3H2 giving 2NH3. If I apply law of mass action on this equation right here, we have already studied law of mass action, so let's apply it here. The rate of the reaction will be directly proportional to concentration of N2 raised to 1 into concentration of H2 raised to 3. Because 1 and 3 are the respective stoichiometric coefficients of N2 and H2. So this will be the expression for the law of mass action. Now here, if I add up these exponents, that is 1 plus 3, this is going to give me 4. And this 4 indicates the number of collisions, the number of molecules which are colliding for this reaction to take place. This is nothing but molecularity of the reaction. So molecularity talks about the number of collisions that take place in order for a reaction to happen. So let's understand the proper definition of molecularity. The number of reacting species which collide simultaneously to bring about a chemical reaction is called as molecularity of the reaction. This word simultaneously is very important here, my dear students. So the number of reacting species which collide simultaneously to bring about a chemical reaction is called as molecularity of the reaction. Let's try and understand molecularity with the help of some examples. So there we go, the first reaction. H2O2 giving H2O plus half O2. In this case, there's just one molecule of H2O2 which is bringing about the reaction. So I can say the molecularity is 1, or that it is a unimolecular reaction. Its molecularity is 1, so we call it unimolecular. For this reaction, NO and O3, that is 2 molecules are colliding simultaneously. So the molecularity also will be 2, which means that it's a bimolecular reaction. For this reaction, now we can see that 3 molecules are colliding simultaneously to bring about the reaction. So I can say that it's a trimolecular reaction, which means that 3 is the molecularity for this reaction. Take this reaction now, NH4NO2 decomposing to produce N2 and water. Once again, I can see that just one molecule is decomposing to bring about the reaction, which means, once again, it's a unimolecular reaction. Or if you consider this one right here, 2HI giving products. 2 molecules of HI are participating in this reaction. That means it's a bimolecular reaction. The molecularity is 2. Now, this is really very simple, but what about such a chemical reaction? 5Br minus plus BrO3 plus 6H plus giving products. Please don't make such kind of faces. It's really very simple if you think about it. I can see that the molecularity is somewhere around 12. Actually, it is 12, not somewhere around 12. But if you really think about what is a collision, you will understand the fact that simultaneous collision of 3 or more molecules is uncommon. Why just molecules? Simultaneous collision of 3 or more particles itself is uncommon. And here the molecularity is 12, which means 12 molecules in the same ratio are colliding simultaneously. That sounds a little weird, right? such reactions are complex reactions, which means that such reactions take place in a sequence of 2 or more consecutive steps. We have already studied such reactions under mechanisms. But in case if you haven't, there's no need to worry about it. Such reactions take place in a series of steps, so these 12 particles don't collide simultaneously. Every single step will have its own value of molecularity. So this is the thing, when molecularity is more than 3, more often than not, it is a complex reaction. It takes place in multiple steps. Now let me ask you a question. Can molecularity be 0? Can 0 molecules produce products? Obviously no. Can -1 or -2 molecules produce products? Again, that's not possible. Can 1.7 molecules produce 5.3 molecules? No. Which means molecularity cannot be 0, it cannot be negative, and it cannot be fractional. It has to be a positive integer value. So this explains the concept of molecularity. That's all for this module. In the next module, we will study order of the reaction. Till then, take care.